Thanks very much, Murray and Hayley. I can see there are lots of questions coming in. What I'm going to try and do is group some of the questions for you, if that's okay. And we've also got some questions that people submitted ahead of the seminar. So we bring the questions back up. So the first question is one about really understanding the choice of cities. So you mentioned 6 cities. Could you say how they were chosen, Hayley, and what the other cities actually are?
We chose them to give a geographical spread across the UK. So as I said already, one of them is Newcastle, and we are planning on looking at also London, Carlisle, Greater Manchester, Glasgow, and a city in Wales as well, Rhondda Cynon Taf. So basically they reflect a different range of physiography, climate, and range of exposure. So there's some smaller cities and some larger cities as well. So the idea was to kind of, I suppose, have a look at some different potential climates, orography, etc., and small and large cities to see if there's any patterns emerge in terms of where we might be wanting to use more detailed models than what's perhaps previously been used to produce these surface water flood maps.
Okay, thank you. We've got a couple of questions on the statistical method. So let's take both of those together. So the first one's from Nick, and he raises a concern about smoothing via a GAM approach when you're looking at very localized events, like the Canadian example. I guess that's the one you showed in the movie at the start. He highlights that in this case, it's not clear that local cells would have similar values. And I think there's a related question on the spatial approach you're taking to the statistics. Just asking you to clarify how you're considering the spatial correlation in the approach to extreme events.
Okay, I think the first question, I agree that these are very local scale events, but at the same time, you wouldn't expect that the return level for an individual location for a particular return period would vary that much from its sort of nearby, from nearby locations, yeah? So although, we're not talking about prediction and forecasting here. We're not talking about where a rainfall event might fall. I guess we're talking about fitting extreme value distributions to different locations that consider both events that fall at that location, but also taking information from surrounding locations as well. So the idea behind a GAM approach is that you're really smoothing the parameters that you're fitting, because you're fitting for every grid cell at once, and you're fitting an extreme value distribution, because then you can use that extreme value distribution to actually estimate these return levels. The idea is that your parameters will be relatively smoothly varying across space. The problem with the previous approach that we've used is that we've basically taken, we've taken, say, the same 40 values, the 2 biggest values per year, for example, and fitted an extreme value distribution to each individual grid cell. And the problem with that, of course, is if you get a lot of extreme events in the control period in that particular grid cell, but you don't in the future, you will get a reduction in uplift for that grid cell, yeah? Whereas actually that might not be realistic. It might be that you kind of need to consider a more robust estimate of that return level at an individual grid cell. So although, I think I can understand there are still issues with these types of models, and you need to make sure that you carefully consider what covariates to use. you know, so that you account for those effects that you see at the coasts in terms of bigger events, and you account for the effects that you see with orography. Actually, it appears to me to be a much more robust method in the sense that you account for surrounding grid cells as well. And, you know, it's not exactly the same method that's used in the FEH, where you're pooling data from, you know, a radius around an individual gauge, but it's a sort of similar idea in a way, because you're basically taking information about the extreme value distribution parameters from nearby locations, and then trying to come up with the best estimate for that individual grid cell. That makes sense.
Thanks, Hayley. I mean, it strikes me there's some link here also to the approach the Met Office uses with the improver approach with its numerical weather forecasts, and we're looking to see whether we can also get some value for that on climate timescales. So it might be interesting to compare offline those different approaches, because I think they're seeking to do some of the same thing. Mm-hmm. We've got a question from Helen that I think has come up in several different guises. It's really looking to understand what the plans are for translating the research outputs to risks and response planning. And I think we've heard some of that from Murray already, but it'd be good if you could both maybe expand on what you'll do as the program develops and how you're interacting with the users.
Well, I mean, I've been certainly talking to the relevant people at the Environment Agency and the Scottish Environment Protection Agency about the updating of their guidance, and talking about when that might be possible. I know that everybody's keen to get these uplifts out, and I think in a way it's kind of we can provide what they need, and it's up to them to then decide how they update their guidance. We can only kind of, you know, we can work together to basically produce what people want, and then, but it's not up to me to sort of decide how to update actual guidance, national guidance. That's up to other people to decide. In terms of the flood risk mapping side of things and these surface water flood maps, really what we're doing in this project is showing the differences between using these new very high resolution dynamic modelling approaches and perhaps older approaches, and then also looking at the impact of the new uplifts as well on the potential changes in flooding that we see in surface water flooding in these locations, and then making recommendations for perhaps additional work that might want to be done to update the surface water maps. We're not going to actually be doing that as part of this project. So, you know, a lot of this project is making recommendations, providing these new uplifts, and then making recommendations for additional work that needs to be done. It's only a 12-month project at the end of the day.
Great, and I'm sure the events that the Resilience Champions are organising over the next few months can also help with connecting to a wider range of users. Mm-hmm. There are some questions that relate to an aspect of scenario uncertainty. So we've got one of these from Matthew from Anglian Water in the questions that were sent in earlier. And he's asking, how does this work support the TCFD ambition to be able to describe risks in terms of a 2-degree world and a 4-degree world? And we've got the related question from Suraj, asking about the use of RCP 8.5 and how that might be framed in the Q&A section. Would you or Murray like to help with those?
Well, I mean, obviously for both the CCRA3 and TCFD, it would be useful to consider changes in, I suppose to produce uplifts for a 2-degree, 3-degree and 4-degree world. And this is something we were talking about a few days ago, actually, myself and Lizzie in about how we might be able to do this. Obviously, we only have information from these 12 convection permitting models in terms of the potential uplifts to the actual hourly rainfall. But what we can do is we can relate that back to the change in global mean temperature from the global models that drive these convection permitting models. And we can see if we can produce some kind of scaling relationships. And we can also look at, because we have much longer time series, we have 100-year time series for the convection permitting model from 1981 to 2081, I think. Then we can also look at the evolution, I suppose, of uplifts through time with temperature change. I don't know what to suggest about the use of only RCP 8.5. I mean, the other thing that we can do, I assume, is to basically try and scale this based on temperature back to other RCP scenarios, which is what has been done in the past for previous climate projections in the UK, where they haven't run all the different emission scenarios. They've used I think what it's called, scaling on global mean surface temperatures, basically, to produce these estimates.
Oh, a pattern scaling.
Pattern scaling, that's what it's called. I was trying to remember the word. Yeah, pattern scaling.
At some point, we might also be able to fill in between the time slices, and that really does open up then, I think, the option of time shifting approaches as well, which is, I think, is an important issue. We've got time for just one last question, and I want to take one of the ones that were sent in advance from Rachel Fisher at the University of Birmingham. So Rachel asks about, could we use the same approach to national infrastructure networks? She gives the example of power or transport.
Maybe I could respond on that.
Oh, yes, please, Murray.
If that's all right. It's somewhat aligned with what Hayley was saying earlier, that this research is going to hopefully help inform the regulators in developing their guidance, which is online. I mean, the Environment Agency guidance is online for flood risk allowances due to climate change for England, and obviously the other regulators have got guidance available, so that guidance is applicable for a wide range of industries and organisations. So the guidance is the place to go to, because that's what's produced by the regulators. This is science and research which is helping to inform that.
Excellent, thanks Murray. We're coming to the end now of the hour. There are some questions we haven't got through. Hopefully, Hayley and Murray, you'll be able to pick up on a few of those after the seminar, and we can put the answers online alongside the slides and the recording. What I would like to do now is first thank our two speakers. I know it's difficult when we can't hear the clapping, but everybody is definitely clapping with their microphones muted. I'd also like to give a plug for the next of these seminars. So Susie, could you advance the slide, please? Okay, so the next one is on the 8th of July. The speaker is Kate Lonsdale, who's one of the Resilience Champions, and Tom Hughes from the National Infrastructure Commission. And they'll be looking about really the topic of what does creating resilience in the UK mean? And the very difficult task of how do we achieve it? So hopefully I'll see many of you again at the next webinar. Thank you very much.